Good afternoon. Today I'm going to discuss some issues of conductor traces versus the mechanical mounting of a printed circuit board. One of the things that we want to avoid is to clamp onto the traces that are not ground. We don't want to clamp over a power trace for sure, and we don't want to clamp over signal traces because it's possible we can penetrate the solder mask and create some kind of a short. With the IDF format, you do not get the information about the traces into your mechanical software, and so it's difficult to actually verify once the board's been designed that you're not creating such a violation. But with Artworks Exporter, you can actually export the trace data on the top and the bottom layer into SolidWorks and do an interference test between your clamping elements and your traces. In order to make this even simpler, we can filter out all of the ground nets which we're allowed to clamp over and just analyze the power and signal nets. So how do we do that? Well, we use a program called AWR out. We'll apply some filters so that we get only what we want. We're going to apply the net filter, going to select the net called ground, then going to turn it around. We're going to extract everything but the ground net into our 3D data. We're also going to apply the layer filter because we don't care what's going on the inner layers or on the bottom at this point. We'll do the bottom separately. So we'll click that to the add. Let's call this test card top. Let's go to our other setting. We're going to unionize all the data on the conductor layers, and the reason we're going to do that is so that the interference test runs correctly. So let's just press OK, and there's our output. So I'm going to use the 3D viewer to look at what we have. The file we just created was test card top. There we are. You can see that we have a lot less conductor circuitry than we started with because most of the top was in fact covered with ground plane or pads. Let's have a closer look. And you can see that we actually have retained the thickness of the conductor. These are going to be proper solid bodies in SolidWorks, unlike some other tools that give you just a 2D representation which you can't use for interference. You can actually use this data and interfere it against your mechanical clamp and find out whether there's any problems or not. So let's import that into SolidWorks next. To import this data into SolidWorks, we're going to use a plugin called Read3DI. We'll start by selecting our 3DI file we just created. We need to set where we want the output to go, and it'll create its own directory. And the only parameter is the one for recovering arcs. So all we have to do now is to click on Import. It should only take a few seconds to bring this data in. And there we have our data. So let's zoom in and see what we have. This was our original outline of our finger, and this is the extruded body. You can tell that by going here to the part called top, and you'll see that the part called top consists of 75 solid bodies. They're all extrusions, or in the case of there's any holes, you'll see a few cuts. You can then run this against your mechanical clamps and check for any interference between the two. Thank you.